You've reached the end of your high school chemistry school year, and you're now thinking about what do you want your students to take away after a whole year of content, including lots of labs, lots of demos. How can you best prepare them for that final assessment? So much content that you've covered, from the atom all the way to the periodic table, bonding, chemical reactions. Let's not forget gases, solutions, thermochemistry, kinetics, acids and bases, and redox, and maybe some engineering and design. What do you want your students to remember? A proven method for remembering beyond just the final exam is through active recall. This means we do not have them simply read the summaries of these labs, either from their own lab handouts or from the textbook. Instead, what I would suggest that you do with your students is to set up stations. If you were to walk into my classroom right now, these 10 stations are set up and ready to roll for tomorrow. If you want your copy of these stations, check the description in the video below and they will be yours to keep. I'm in no way suggesting that these are the must-do 10 stations. If you don't like a particular station because it doesn't match with what you want your students to take away, flip one out and instead insert yours in there to make it tailored to your needs. I also don't mean for this list to be entirely comprehensive. I chose those particular demos and labs that I think my students really need that active recall for those particular labs. All right, let's get started with those 10 must-do Chem recap lab stations. First station emphasizes the collision theory. How can you increase the rate of a chemical reaction? I will be demoing for them again the explosive reaction involving 40% hydrogen peroxide with a catalyst added, and then I will ask them some questions that might help them remember what 4 factors allows a reaction to be sped up. 2, really key is I want them to remember what determines electrical conductivity. I'm going to have them play with either salt water, they will make the solution themselves, distilled water, and tap water. And they can use either the conductivity meter pictured in the slide, or I also have a digital one that shows you an actual number in parts per million. Either way, they're supposed to give me a quantitative answer, including why are these solutions or substances conducting, yes or no? What are the relevant particles? 3, another concept that my students were struggling with is how to actually calculate the atomic mass. We've done a lab in the beginning of the year involving the benium element, and so they are able to recount and remeasure the mass of the 3 different types of beans. And if for some reason a student is not present during this lab time, they can use the data that's right here in the picture and calculate the atomic mass that way. 4, I have ready for them a gas electric tube connected to the outlet so that they can actually really observe the neon bright line spectrum. But again, for those students that may not be present or they're online, you can actually see the spectrum right here. Can they explain why we are able to observe this particular bright line spectrum and which subatomic particle is the cause of this spectrum? 5, we spend a lot of time in my classroom using the storyline, why do some things get colder or hotter when they react? And that storyline involved modeling the breaking and making of bonds, as demoed in this particular slide with the 2 GIF animations. The video linked above explains this in detail, how to model making and breaking bonds. And my setup in my classroom is ready to roll so that they can remodel the concept of breaking and making bonds that are so key to chemical reactions. 6, this concept I did not emphasize enough. They probably saw this during their biology class or living environment, depending on what it may be called. So I set this up for them to really see this actually for the first time in the chemistry classroom. And they are supposed to take away that chromatography is a physical separation process that is based on polarity of the molecules at play. In this case, a variety of dyes that have been mixed together that can now easily be separated using chromatography paper and some kind of solution that includes water. 7 is another item that I haven't really emphasized enough in my classroom, and that is the setup of a distillation, which you can so nicely see in this video that 2 students have used to actually create distilled water from tap water or water from around their house from a stream. And distillation, of course, is a process that centers around boiling point differences. 8. What is the purpose of titration? A concept that I've definitely covered earlier this year. And I'm showing them in my lab another setup, including a burette, the stopcock, the flask, and also a micro titration setup that we really did in my classroom, involving a well plate and a balance. So using mass instead of volume to determine the concentration of the analyte, the unknown. Check out my video linked above that explains this micro titration setup in great detail. 9. How can you best construct a basic voltaic cell? And again, you've probably noticed I really like the micro level of doing things. So again, here you see a well plate with a copper boat that's connected to an alligator clip, and on the other side, a magnesium strip also connected to an alligator clip, and then with a voltmeter in between. And that shows them if you indeed insert a salt bridge, a voltage can be measured. And since we did both a magnesium copper and zinc copper in our lab before, hopefully this picture and the setup ready to be built will prompt them through active recall that the magnesium copper cell is going to give them a higher voltage than the zinc copper cell. 10. What is an electrolytic cell, unlike the one in the previous slide, which is a voltaic or galvanic cell? Here's your Hoffman apparatus. And obviously this setup can show students how you can electrocute, so to speak, water to separate it into its composing atoms, namely through the release of hydrogen and oxygen gas in that wonderful stoichiometric relationship. For every 2 moles of hydrogen, 1 mole of oxygen is produced. And if the setup actually works very well, it didn't last week, I'll try it again, then maybe you get that beautiful pop test again with a minor explosion to show that indeed you've created that hydrogen gas. And finally, I did insert one bonus question, and that enables my students to go back to Science Daily, which is one particular source that I'd like them to use to come up with a science topic or a science concept that has been researched and peer-reviewed and that really piques their interest, and that they can take a screenshot of and then summarize to delve a little bit deeper into that particular study. In conclusion, I've shown you here 10 individual lab or demo stations that encourage students through active recall to memorize labs or other activities or demonstrations that they've seen or done earlier in the school year. And by making this more hands-on, it basically promotes them reviewing and learning this for the final chemistry exam coming up very soon. And so there's nothing better than to end this video with the Dutch word for chemistry, which is not an easy word to pronounce. So repeat after me. Scheikunde. Scheikunde. Schei really refers to the process of decomposition. So you're basically starting with atoms that you can no further decompose. And kunde means science. So the science of starting with atoms and how they combine to react. Scheikunde. Thank you very much for watching and see you in the next video. Bedankt voor het kijken en tot ziens!